Now, we can also check statistically whether the slopes of the regression lines are the same for the three conditions. So the first thing we need to do is unsplit the file. So we just click on that, analyze all cases. So now the file is all back together and it says split file off. So I'll just flip back to the data. Now what we do is we use analysis of variance. So we do general linear model and we go into univariate. Now these are already in here from what I was doing before. So what we want to do is do analysis of covariance, but this isn't actually the analysis of covariance. This is the test for the homogeneity of regression. But what we want to do is take our pretest and put that into the covariate. Then click on the model button and change this from full factorial to custom. Now we take training, say main effects, and we put that over there. And pretest, main effects, put that over there. Then you need to select both of them. So if you hold down Shift and click on both and select interaction, we can then put that over here. And this will tell us whether there's an interaction between the pretest scores and the type of training in terms of how well that affects the post-test score, the dependent variable. Hit continue. Options should still be okay. Yep. Continue and okay. Now quite simply what we're looking for here in order to ensure homogeneity of regression is for this interaction term in the table, training by pretest 1, we want this to be not significant. Okay, it's 0.427, so that means that the predictive value of pretest score of the post-test score is the same for all three groups. So in other words, the slopes of the lines that we saw in the regression analysis are the same for all three conditions. And that's okay. That means we can now actually go on and do analysis of covariance. If this comes out to be significant, so you don't have homogeneity of regression, you have heterogeneity of regression, then you can't do analysis of covariance because it doesn't meet the assumptions and the results won't be valid. In fact, it can actually have a detrimental effect. If you try to do it when it isn't appropriate, it can give you very strange results that don't make any sense.